we're going to be calculating the mass percent of different elements within a compound, and the mass percent is as always the part over the whole times 100%. Now, to make things easy for ourselves, we're going to take the whole to be 1 mole of the compound. So the mass of the part is going to be the mass of element X, whatever element X is, in 1 mole of the compound. The mass of 1 mole of the compound is its formula weight. So we need to determine the formula weight of sucrose. So we calculated our formula weight, which we did by adding together the mass of each element that was involved in the compound. So here we've calculated the formula weight of sucrose. We had 12 carbon atoms, each weighing 12.01. We got this from the periodic table. 22 hydrogens and 11 oxygens. So we're able to calculate this way the mass of an entire mole. But we also appreciate that this is the carbon, this is the mass from the hydrogen, and this is the mass from the oxygen. Knowing this simplifies our calculations. So we can get the percent carbon by multiplying the mass of carbon, 12 atoms times 12.01 grams per mole per atom, divided by our entire formula weight. And for both the numerator and the denominator, we know our units are grams per mole. So what we are saying here is we have 12 times 12.01 grams per mole of carbon out of the entire mole. So if we multiply this by our 100%, we get our mass percent carbon, which comes out to be 42.09849%. And we're told to use 3 sig figs in our answer, so we can round this to 42.1%. So we can figure out the mass percent of our remaining elements the same way. And again, we use 3 sig figs in our answer as we were directed. And finally, we can get our percent composition of oxygen by the mass of oxygen in 1 mole. Let's recap. We're calculating the percent composition, which is the percent by mass of each element in the compound. And to make our math easy, we assume we have 1 mole. So the denominator, the mass of the whole, is simply the formula weight of that compound. And we figure out the mass of each element by the number of that element multiplied by its atomic weight. And this way we get the mass percent, the mass of the part, over the mass of the whole times 100%. In this problem, we're going to use the percent by mass in order to determine how many grams of the part, grams of carbon, there are in the whole of this amount of glucose. 40.03% by mass carbon means that if we had exactly 100 grams of the compound, that means that we have 40.03 grams of the carbon. And we're going to use the percent as a conversion factor. This identity here means we can write two conversion factors. We can say 100 grams of the compound is equivalent to 40.03 grams of carbon. And we can also write that 40.03 grams of carbon and glucose means that we have exactly 100 grams of the compound. So we choose a conversion factor based on which conversion factor cancels the appropriate units. Here we start with 16.55 grams of the compound, and we want to use the conversion factor that cancels grams of compound. So 100 grams of the compound is equivalent to 40.03 grams of carbon. And if we do the math, this comes out to be 6.624965 grams. Okay, we have a couple extra sig figs here. Now if we want to worry about the sig figs, here we have 4. Here we also have 4 sig figs. Now remember, we assumed exactly 100 grams of the compound, so this 100 grams does not impact the sig figs. So we're going to use 4 sig figs in our answer. 1, 2, 3, 4. We're going to round up. And that means we have 6.625 grams of carbon. You likely recognize we could get the same result had we done the problem slightly differently. We would start with 16.55 grams of the compound and multiply that by the percent expressed as a decimal. So 40.03% is 0.4003. And that gives us the same answer. I'll go right to the right number of sig figs. Okay, and this is possible because we recognize